Welcome. In this module, we will explore the core application hosting options available in Microsoft Azure. We will navigate the spectrum of compute services, ranging from virtual machines, which offer maximum control, to containers for portability, and finally, to Azure App Service for managed web hosting. By the end of this session, you will understand how to select the right environment for your specific workload needs. To choose a hosting option, you must first understand the trade-off between control and management. Azure Compute Services generally fall into Infrastructure as a Service, IaaS, or Platform as a Service, PaaS. On one end, we have virtual machines, IaaS, where you have total control over the operating system, but also bear the responsibility for patching and maintenance. On the other end, we have web apps, PaaS, where Azure manages the underlying infrastructure, allowing you to focus solely on your code. Sitting somewhere in the middle are containers, which offer a blend of portability and isolation. Your decision depends on whether you need to control the OS or if you prefer a managed platform that handles the heavy lifting for you. This diagram visualizes the three primary hosting categories. Starting from hosting options, we branch into virtual machines, containers, and Azure App Service. The virtual machines branch leads to IaaS, highlighting high control. The containers branch emphasizes portability. The Azure App Service branch leads to PaaS, highlighting high productivity as the key benefit. Let's start with Azure Virtual Machines. A VM is essentially a software emulation of a physical computer. It gives you total control over the operating system, whether it is Windows or Linux. This makes VMs the ideal choice for lift and shift scenarios where you need to move an application from your local data center to the cloud without rewriting code. Because you have full access to the OS, you can install custom software or specialized configurations that might not be supported by PaaS options. However, this control comes with responsibility. You must manage OS updates, security patches, and the configuration of the middleware yourself. This block diagram shows the stack of a virtual machine. The top block represents what you manage: the application, middleware, and crucially, the guest OS. This is highlighted in orange to show your responsibility. The bottom block, highlighted in blue, shows what Azure manages: the hypervisor and physical hardware, abstracting the physical data center away from you. Next, we have containers. Unlike VMs that virtualize the hardware, containers virtualization happens at the operating system level. A container bundles your application with all its dependencies and libraries, ensuring it runs the same way everywhere. Because they share the host OS kernel, they are lighter and start faster than VMs. Azure offers two main ways to run them: Azure Container Instances, ACI, and Azure Kubernetes Service, AKS. ACI is perfect for simple applications or tasks where you want to run a container in seconds without provisioning infrastructure. AKS is an orchestration service used when you need to manage complex, multi-container applications at scale. This diagram illustrates container architecture. At the bottom is the host OS kernel, which is shared. Branching up are three distinct containers, each holding its own app and libs. This visualizes how they share the underlying system resources. The subgraph below lists the Azure services: ACI for speed and simplicity, and AKS for scale and orchestration. If your goal is simply to host a website or a web API, Azure App Service is often the best choice. This is a platform as a service, PaaS, offering that abstracts away the virtual machine, operating system, and runtime patches. You simply deploy your code whether it is .NET, Java, Node, JS, or Python, and Azure handles the rest. App Service includes powerful built-in features like auto-scaling to handle traffic spikes, load balancing, and deployment slots for zero downtime updates. It is designed to maximize developer productivity by removing the burden of infrastructure maintenance. This class diagram explains the relationship in App Service. The App Service Plan class represents the underlying compute resources and scaling rules. The Web App class represents your specific code and configuration. The arrow indicates that the App Service Plan hosts the web app, showing that you pay for the plan, but deploy the app on top of it. How do these options handle growth? For virtual machines, we use Virtual Machine Scale Sets, VMSS. This allows you to create and manage a group of identical, load-balanced VMs that can automatically increase or decrease in number based on demand. For App Service, scaling is built in. You can scale up by moving to a larger pricing tier or scale out by increasing the number of instances handling requests. For containers using AKS, the orchestrator handles scaling automatically, adding more pods for your application, or even adding more nodes to the cluster if the physical resources run low. This state diagram shows the response to demand increase. The path splits into 3 actions based on the service. VMSS adds a VM instance, App Service adds a plan instance, and AKS adds a pod or node. All 3 paths converge at load balanced, illustrating that regardless of the method, the end goal is distributing traffic across scaled resources. So, how do you decide? Use virtual machines when you need absolute control over the operating system or are migrating legacy applications that require specific OS configurations. Choose containers if you are building microservices, need to run the same application in different environments, dev, test, prod, or want higher density on your hardware. Finally, choose Azure App Service for standard web and mobile applications where your priority is development speed and you want Microsoft to manage the security and patching of the infrastructure. This flowchart guides your decision. Started app requirements. First, ask need OS control. If yes, choose virtual machines. If no, ask web or API only. If yes, choose app service. If no, implying complex or portable workloads, choose containers. This logic simplifies the selection process. In summary, Azure provides a comprehensive range of hosting options. Virtual machines offer IaaS for maximum control over the environment. Azure App Service offers PaaS for maximum productivity in web development. Containers provide a modern, portable solution for diverse applications. Crucially, regardless of which compute option you choose, they all integrate seamlessly with Azure Virtual Networks, allowing you to secure your connectivity and isolate your resources. By understanding these core components, you can architect solutions that are scalable, secure, and cost-effective. The final mind map centers on Azure Compute. It branches into the 3 main pillars we discussed. Virtual machines are linked to control and OS management. App Service is linked to productivity and web/API. Containers are linked to portability and microservices. This provides a mental snapshot of the core value proposition for each service.